The first thing we want to establish when we are solving root equations is that in this video, at least, we are not going to use any complex numbers. So no complex numbers. Only, comma, only real numbers. Yes. Otherwise, things start getting out of control if we take roots and we allow complex numbers to get in. Yep. Let's do a few problems. The first one is super duper easy. Okay, so 5x minus 1 equals -7. Okay, this problem has no solution. No solution. Why not? When we write down a root, we mean the principal root. And that means the positive number. So there is no way that this root is going to give us a negative number unless we are in the set of complex numbers. But we just established that in this study of root equations, we're not going to deal with complex numbers. So this equation has no real solution. Yeah, maybe we should emphasize that. No real solution. Yep. Yep. So, and all we have to do is observe, okay, and let me explain a little longer or elaborate a little bit. Okay, so this symbol, okay, the symbol represents the principal root. Yep. So the principal root is the positive one whenever there are a positive and a negative. With cubic roots, that's not the case. With cubic roots, yeah, you can have the cube root, whoops, that's a 3. The cube root of -64, and that is -4, and that is not a problem because the cube roots, there's only one. For square roots, there are 2. And so when we put down the symbol, this symbol, we mean the positive one represents the principal root, the positive one. Hence, square root 5x minus 1 can't be -7. Yeah, because that is a negative number. So there is no solution at all whatsoever for that equation. So make sure you know that because that is important. You know, you can save yourself a lot of time. You can start solving this equation just to get to the point where you get a number and then you plug it back and it doesn't work. Yeah. So for instance, 10, if x was 10, you know, somebody may say, wait a minute, 5 times 10 is 50 minus 1 is 49. Square root of 49 is 7. Well, you would be doing all that work just to realize we cannot have a negative number. So you can save yourself a lot of time just by observing the equation and realize, oh, this has no solution because the output of this has to be positive, maybe 0, but definitely not negative. Again, the reason for that is because we're dealing with no complex numbers. Now, if we had instead square root of 5x minus 1 equals +7, okay, then maybe there is a solution. So we investigate. We square both sides of the equation. So I'm just going to say that we're going to square both sides of the equation. So when we square this, we end up with no root. 5x minus 1 equals the square of that would be 49. Add 1 to both sides of the equation. So 5x equals 50. divide by 5, x equals 10, but stop. Don't box your solution. Don't say, oh, there's my solution. Make sure it works. Because when we square equations, there is the possibility we may be introducing what is called strenuous solutions. So in order to detect strenuous solutions, what you have to do is check them. Check each one of the solutions because some may work, some may not work. Okay, so I can tell, and you don't have to show a lot of the work. If the equation is simple enough, by inspection, you can tell, well, 5 times 10 is 50, minus 1 is 49, square root of 49, 7, it checks. So now that I checked it, yes, I can box it and say, this is my final solution for that equation. Okay, so the rule is that if we square an equation, we may be inadvertently introducing what is called extraneous, there's an X in there, extraneous solutions. Yeah, solutions that don't belong really. Yeah, some solutions may filter in to the party when they were not invited. That's what happens when we square things. In general, when we multiply by a variable, that could happen. So extraneous solutions. So we must absolutely have to check each one of the, well, I cannot call them solutions yet, each one of the candidates for solutions. See, before I check that 10 actually works, it wasn't a solution yet. It was a candidate. And then we put it back into the equation, it works, we're good. And that's the only solution that we will encounter. So by squaring, we may end up with more candidates, but not fewer. When we divide is when we end up with fewer. So that's what we gotta watch out for when we divide. But when we multiply or when we square, there's gonna be extra solutions. Example 3. Say you have the square root of x plus 51 equals x minus 5. All right. This almost guarantees that we're going to have a strenuous solution. So, yeah, let's just do this. So square both sides of the equation, and we end up, I'm going to move a little bit to my left, x plus 51. So when we square that, that's what we obtain. Now, when we square this, we got to be careful. That's equal to x minus 5 quantity squared, which we have to FOIL out. X minus 5 times x minus 5. So I'm going to do that in the next step, just to be sure. So x times x is x squared. X times negative 5 is negative 5x. X negative 5 times x, negative 5x. And then negative 5 times negative 5 plus 25. Okay, of course, that is going to simplify to negative 10x. But then there's another x that we can subtract from both sides of the equation. So 0 equals x squared minus, remember, that is negative 10x. We're going to subtract an additional x. So now we have 11x that we're subtracting from x squared, 25. And we got to subtract 51 from it. 25 minus 51 is negative 26. Excuse me. So we can factor this, x minus 13 and x plus 2. And now we use, you know what we're going to use. We're going to use the zero product principle, which states that if a product equals 0, then at least one of those two has to be 0. And we have to come up with all the possibilities. So on one hand, x minus 13 is equal to 0. On the other hand, x plus 2 is equal to 0. In this case, x equals 13. And in this case, x equals negative 2. At this point, they are candidates. We don't know if the two of them or one of them, and if it's one, we don't know which one will be a solution, if any of them at all. So there are 4 possibilities. The two of them work. This works, but this one doesn't. That works, but the other one doesn't, or neither one works. Let's check 13. And when the problem is complicated enough, we can just write this down, but I'm thinking this, we can do this in our head. 13 plus 51 is 64. Square root of 64 is 8. Now remember, that's 8 on the left side of the equation. 13 again, minus 5 is 8. It checks. 8 equals 8, so we're good. This 13 works. We're going to keep it. This guy, on the other hand, let's see, 15 minus 2, because x is negative 2 in this case, is 49. That's nice. We can take the square root of 49, and we end up with 7. If x is negative 2, negative 2 minus 5 is negative 7. Whoa. So this turns out to be negative 7, while this is positive 7 because this is the principal root. Whoa. So that means we have a mismatch, 7 versus negative 7. They're close. One is positive, the other one is negative. I mean, they're the same number. One is positive, the other one is negative. So they may seem like this is a solution, but it isn't. There's a huge gap between negative 7 and 7. So we reject this guy. Reject. And this is a keeper. And so this is the only solution, 13, not negative 2. That's why, and we don't know in advance which one will work. Somebody would say, well, just reject the negative. Not necessarily. Sometimes that is the case. Sometimes that is not the case. And we don't know in advance. So just because a number is negative, don't jump and reject it. Have a good reason to reject a number, such as it doesn't work, but not just because the poor number is negative. That it doesn't work that way. All right. How about square root of x plus 44 equals x plus 2? All right, so we're going to square both sides, x plus 44. And now remember, we're going to FOIL this, x plus 2 quantity squared. So we have x plus 2 times x plus 2. Okay, and again, x times x squared. X times 2 is 2x. 2x again. 2 times 2 is 4. Sorry to not finish this up here. I finish on the next little line. So x plus 100, just 44 equals x squared plus 4x plus 4. Take away the x. So 0 equals x squared plus 3x. Subtract x on both sides of the equation and subtract 44. Minus 40. All right, so we factor this out. X and something, x 40, 10 times 4, we would need the 3. 20 times 2, nope. 5 and 8. Oh, 5 and 8 will do. Plus 8 minus 5. Yep. So by the zero product property, x plus 8 could be 0, or x minus 5 could be 0. So x equals negative 8 or x equals 5. Now, somebody may say, wait a minute, so that's not the answer. We don't know. Don't jump to conclusions. One of the things I've learned in mathematics is not to jump to conclusions. I can tell, though, as I'm looking up here, negative 8 plus 2 is going to be negative 6. So regardless of what this turns out to be, we have a principal root, which is a positive number, or 0, equaling negative 6. Because if we plug in negative 8, we end up with negative 6. That is going to cause a problem. So yes, after plugging in, we check, oh yeah, we got to reject this guy. And now, don't just embrace this one automatically. Wait a minute. Let's see if it works. We could be that both are rejected. We don't know that. 5 plus 2 is 7. Okay, so at least that makes sense. 5 plus 44 is 49. Square root of 49 is 7. So that we have a match. Yep. So this guy is a keeper. So do not jump to conclusions and say, oh, one works. No, one doesn't work, consequently, the other one should work. No, 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 no. We don't know in advance. Yep. Example, let me keep track of the numbers. Example 5. 2 times square root of x plus 2 equals 1 minus x. All right. As usual, we're going to square this, and we're going to square that. Now, squaring this is a little more tricky, because we got to square that and square that. We're multiplying. So when we are squaring, we distribute the squaring across the factors. So we end up with 4. That's the square of the 2. And the square of the root is the quantity x plus 2. And now we're going to square that. Remember, we have to FOIL. So 1 times 1 is 1. 1 times negative x is negative x. Now, you don't have to show all the steps. If you are proficient in foiling, then you can just write down what it is. Yeah, I'm showing blow by blow how we obtain the foiling, the squaring. But if you say, oh, I know how to go from here to here, go right ahead. Yeah, some students are very proficient at foiling, and that is very good. That means you had good teachers, or that means that you put your time and effort into it. Anyway, while we do that on the right side, on the left side, we can distribute. So we have 4x plus 8, 4x plus 8. And now let's move everything to this side of the equation, because that's the one that has a positive x squared. So 0 equals x squared. That takes care of that. And then we have a negative 2x's. But then we're going to subtract 4x from both sides of the equation. So we have actually negative 6x's. And then 1. But then we're going to take away 8 minus 7. Okay. So that factors into x minus 7, if I'm not mistaken, x plus 1. So we use the zero product property. And so x minus 7 is equal to 0, in which case x is 7, and x plus 1 is equal to 0, in which case x is negative 1. And we're probably thinking, Well, we're going to reject that guy. I can tell from a mile away. That's a negative. Well, not so quick. Not so quick. Let's see. If x is -1, -1 plus 2 is 1, and we can perfectly take the square root of 1, which is going to be 1, times 2 is 2. So this is 2. Again, -1, or 2 minus 1 is 1, root of 1 is 1, times 2 is 2. So the left side is 2. Again, if x is -1, 1 minus -1. Now keep that in mind. 1 minus -1 is also 2. So we have a match. 2, 2. So that guy is a keeper. Does that mean this is a keeper? Well, we don't know. We don't know until we do this. All right, 7. We're going to test 7. 7 plus 2 is 9. Square root of 9 is 3. 3 times 2, 6. So this side is 6. Okay, we're testing 7. 1 minus 7 is -6. Well, we got a problem. 6 versus -6. We don't have a match. Some of us may be thinking, oh, isn't that close? One is positive, the other one is negative. No, that's a huge difference. So we reject the 7 and we keep the -1. This is the only solution. The other one is a extraneous solution rather. So, yep. We have to test solutions, candidates. So before we tested, they were candidates. They were not solutions yet. Well, there were solutions to that equation, but we didn't know whether there were solutions to the original equation. Always go back to the original equation. See, the thing is, the very first step, when we went from here to here, that's where that 7 snuck in. Yeah, squaring it added a solution, because we could have had x minus, in fact, let's do that. Let's do that. What happens? So I'm going to label this 5 prime. So it's not just the 5. So this is problem 5, and this is 5 prime. I'm just making this up as we go, because now I'm curious. X plus 2 equals x minus 1. So I'm changing the 1 minus x into x minus 1, and you're going to see why. Okay, so square both sides for quantity x plus 2. We did this before. Square that, x minus 1, which we're going to FOIL. So x minus 1 times x minus 1. And that's going to give us x squared, and then negative x, and then negative x again, and 1. So we have x squared minus 2x plus 1. And here we have 4x plus 8 and 4x plus 8 again. So notice when we compare that we end up with the same setup. 4x plus 8, 4x plus 8, x squared minus 2x plus 1, x squared minus 2x plus 1. So we have exactly the same setup. So I'm going to, because we already did this work in problem 5, there's no need to do this. So I'm going to say yada, yada, yada. Okay. Or I should be more explicit. Same as example 5. So we end up with the candidates 7 and -1. X equals 7 and x equals -1. All right. So if we put in 7 here, 7 minus 1 is 6. Okay, that's a good sign, but we got to make sure that it works here. 7 plus 2, 9. Square root of 9 is 3. 3 times 2 is 6. Oh, we got a match. So this is a keeper. Now, that doesn't automatically mean we got to reject this guy, although I think we do, as I'm looking at this. -1 minus 1 is -2. And here we have 2 minus 1 is positive 1. Square root of positive 1 is 1 times 2. So this is negative 2 and this is 2. We have a mismatch. So this is the one we reject in this case, and this is the keeper. But that varies from problem to problem. You know, if we change things around, then that can cause the problem to behave differently than what we perhaps may think. You know, be as it may, we just cannot assume things. Yeah, assuming things can lead to problems. Let me see if we can at least get started with example 6 on this page. Square root of x plus 8, or 8 plus x, equals square root of x plus 2. Okay, that's a little more complicated. I'll show you why. Square both sides, as we've done before. So when we square this, we end up with 8 plus x. And then here we got a binomial. Don't put down x plus 2. That is the fastest way, well, the second fastest way to get this wrong. Don't just put x plus 2 and that's it. No. We have the quantity square root of x plus 2 times itself. So we have to FOIL, just as we did the previous binomials, square root of x plus 2. All right. So square root of x times square root of x, x. Square root of x times 2, 2 root x. 2 root x, added to that. 2 times 2 is 4. Okay, so let me continue on a next page. So 8 plus x, 8 plus x is still equal to x, interesting, plus 2, and I missed the 2 here. Yep. 2 root x plus 2 root x, so we got 4 of them. 4 root x plus 4. Okay. We can subtract the x from both sides of the equation. So those two x's go away. We subtract 8 from both sides of the equation. So we end up with 0 equals 4 root x minus 4, because we're subtracting 8 from 4. So 4 minus 8 is negative 4. Okay. We can add the 4 back into here. I guess we should have just subtracted 4, because I'm doing 2 steps to achieve the same goal of getting just 4 equals 4 times square root of x. And then we can divide by 4. So I'm going to put the square root of x on the other side. Square root of x equals 1. And so the square root of what number gives us 1? And of course, the answer is just 1. So x equals 1. Now, anytime we're solving a root equation, an equation that includes a root, we have to go back and check our answer, because we don't know. We don't know. For all we know, we might have to reject that anyway. Oh, I can tell, and always compare to the original. Because, like in this case, if you compare to a previous step, like this one, or this guy to this equation, it will work. It will work. But this does not work with the original problem. So always compare your candidates for solutions to the original problem. And I can already tell this is going to work, because 9 plus 1 is 9 rather. Square root of 9 is 3. Square root of 1 is 1 plus 2, 3. Yep, 3 equals 3. We're set. That's a keeper. That's the solution. And there's no other solution, because if there was another solution, that would come out of the process. All right. Now, what example number did we do? 6. So now let's do 7. I think I copied my wrong problem. Yeah, let's do this one. 7. Square root of x. I was about to copy the wrong problem. That's what I meant to say. Square root of x minus 8 equals square root of x minus 2. Similar to the problem we just did, problem number 6, but now we got subtraction. That subtraction is not as important as this one. This one is handled different because we have to FOIL. All right, so square both sides. X minus 8 is equal to quantity square root of x minus 2 squared. So we have to FOIL that. Square root of x minus 2 times root x minus 2. Multiply those two to get x. The outer terms minus 2 root x. Inner terms minus 2 root x. Last terms plus 4. So that is x minus 4 because we got subtracting and subtracting again. So 2 and 2, and then 4 again. Okay. Let's continue on a new page. Well, actually, I still have room to write this equation here. Yeah, so we have x minus 8 is the same thing. X minus 8. There we go. So the x simplifies. We can subtract x from both sides of the equation. Now we got negative 4 root x. And I'm going to subtract 4 from both sides of the equation. So this 4 is going to go away. And by subtracting 4, and we also subtract 4 from here, so we end up with negative 12 equals negative 4 root x. Good. So divide by negative 4, that means that root x has to be 3, which means x has to be 9. Square root of what number gives us 3? The only number is 9. That's a candidate. It's not an answer yet. It's not a solution yet. We have to check. Put it back into here. 9 minus 8, 1. Root of 1 is 1. Okay, that's 1. Square root of 9 is 3 minus 2, 1. Yes, it works. So now we declare this as our only solution. Oh, the next one is a little tricky. Square root of x plus 42 equals opposite of x. Now, before you jump off your seat and say, hey, there's no solution because you just said, Mr. Saldivar, on the very first example of this video, if there is a negative, there is no solution. Yes, and I stand by this. If we're dealing with real numbers, that is correct. But that's not the same as that. Be careful. Negative 7 does not mean the same kind of thing as negative x. You're thinking, well, why not? And I can tell you why. If x was a negative number itself, the negative of that would be positive. I know that's kind of hard to wrap our mind around the first time we think of it. See, x, we do not know the value of x. We do not know the nature of x. It could be a positive number. It could be a negative number. It could be 0. We don't know. what we know is that we're doing the opposite. I guess another way to say this is that we really want to think of this negative as opposite of this number. Whatever this number is, we got to do the opposite. So one thing we can establish though, that answer has to be negative. If there is an answer for x, the x has to be negative. Let me write that down. If there is a solution for x, comma, then x has to be negative. Because that is the only way in which when we take the opposite of it, we end up with a positive answer. So this could still be positive if x is negative. So again, that is, initially it is hard to wrap around, our mind around that, but that is the way it is. X could be negative, in which case opposite of that would be positive. So think of the negative as opposite. Okay, or 0. Okay. So again, I just want to emphasize one more time, negative x is not the same as negative x, because negative x may or may not be positive. We don't know. Square both sides. So x plus 42 equals negative x squared, which of course is negative x times negative x. If you're in doubt, just spell it out. Spell out what the squaring is. And then we realize quickly there's 2 negatives. And that is, what is that equal to? Oh, of course, x squared. So if we move the other 2 terms to the other side of the equation, we get a new equation. Which would be 0 equals x squared minus x minus 42. We don't really move them. We just say it that way, but we are really subtracting x from both sides of the equation and subtracting 42 from both sides of the equation. So 42, there we go. And then quickly, we realize that, whoa, I didn't mean to do that. We can factor this as x minus 7 times x plus 6. X minus 7, yep, that works because that gives us the negative 1 and the negative 42. So we have 2 solutions. Well, let me invoke the 0 product property. So x minus 7 is equal to 0, or x plus 6 is equal to 0. So x is 7, or x is negative 6. And some of us might be thinking, I know the answer is negative, is 7. No, 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 no. Remember what we established here. If there is a solution, that solution, that x, has to be negative. So in fact, we have to reject that because that guy is positive. So if we place that 7 in x, we would have equals negative 7. And we cannot have a principal root equaling a negative number. So we have to reject. Isn't that tricky? We have to reject that. On the other hand, if we put negative 6 for x, then we have negative, that negative, but x has a negative 6 within. Yeah, we got yada, 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 yada. So I'm not saying that those 2 are equal. I'm just saying whatever the root. Anyway, here we have, I shouldn't even put an equal at all. I just comparing 2 expressions. So this negative, that negative is this negative. The negative 6 is the value of x that we are testing. So now we got a double negative causing this to be 6, and then that makes sense. Now, the fact that it makes sense doesn't mean that it is correct, that it is accurate, that is the accurate solution. We still have to test it. Okay, so we get 6. If we plug in -6 into x, when we do its opposite, we're going to get positive x. So 42 minus 6, 36. Principal square root of 36 is 6. They match. We're good. So this is a keeper. And so the solution is 6. And that is the only solution. Oh, one more example, 9. What if we have the cube root of 6x plus 4 equals 4? And of course, the 4's don't simplify. That would be bad. Now, the difference is that we have a cube root, not a square root. So we're going to cube both sides of the equations. We cube both sides. Now, when we cube the left side of the equation, the root vanishes, leaving us with 6x plus 4. And then we have to cube the 4. So that is 4 times 4, 16 times 4 is 16 times 4 is 64. So 6x plus 4 equals 64. And from there, the solution dominoes very, very quickly. Because subtract 4, I mean, you can almost see what's going on. Just take away the 4 and you get 6x equals 60. 60 is the same thing as 6 times 10. So x has to be 10. Now, when we are dealing with cubic roots, it is very, in fact, it won't happen. It won't happen that we have an extraneous solutions. So with cube roots, fifth roots, seventh roots, and so forth, whenever we have an odd root, we won't have extraneous solutions. So that is a fact. A fact. If you have even roots, even root equations, may end up with extraneous solutions. Okay, so that's one thing. The other thing is if you have odd root equations, don't have extraneous solutions. One other thing I want to tell you, because I wrote down the root equation. So this is a root equation. Why? Because it has a root in it. This is the root of the equation. Remember, there's something I missed to tell you. The word root, yeah, let me bring back another example. I was almost too efficient. An example that fits in the whole page. Okay, yeah, like this 5 prime. Okay, this is a root equation because it has a root in it. This is the solution. I've been calling it solution of the equation. Solution of equation. But mind that this is also called the root of the equation, or root of equation. Yeah. So root, unfortunately, has been used in 2 different ways.
Are you there? Are you there?
Let me pause.
Are you there? Are you there?
Okay, so sorry about that. There was a telephone call that came in. Um, anyway, what I was mentioning is that the name root can be used for that, or it can be used for the solution of an equation. And that's it. That finishes up our video about root equations.